Hi guys, so in this video I'm going to discuss with you how to design a filtration system for your pool. Okay, this is how we do the basic designing of the filtration system. Okay, so first what we do is we take the pool volume, sorry. First we take the pool volume, okay. So in this case, let's say your pool volume is 50 cubic meter. And say and then if the pool is residential, so if the pool is residential, we have a turnover rate of 6 hours. Basically what that means is this whole pool volume will pass through the filtration system in 6 hours. Okay, so this is the turnover over rate. So for commercial, we have a turnover rate of 4 hours. Okay, now one thing also you have to notice or you have to take into consideration is how often you'll be swimming within the pool. So if you won't be swimming quite often, then you can raise it to 8 hours. Okay, and this one, but commercial, we try not to lower the the turnover rate. So once that's established, what you can do is now you can get the filtration rate per hour, okay, or the filtration volume, sorry. It's the filtration volume per hour. So that will be, let's say, for in this instance we'll take the residential, so that's 50 cubic meter divided by 6, which for which the answer would be 8 cubic meter per hour. Okay, normally what people would do is they'll take a filter, they'll they'll go into a catalog, Hayward or Emox, they'll go to the catalog and they look for a filter which says uh, wherever this 8 cubic meter per hour uh, fits in, right? So there are multiple sizes, right? Size A, B, C, whatever, right? These are the models. So it'll say like 40 cubic meter, 60, 70 volume, that this volume of yours fits in, that's the filter you'll choose, which is not right. Okay, what you want to be doing is you want to take a filter and you want to decide it based on the filter media. If you filter water at 30 meters per hour, okay, so filter media. Now every filter media is different. First of all, what's a filter media? So filter media is like sand. For us, we use AFM, or if you're using DE filter, okay, or if you're using cartridge filters. So the problem with DE filter and cartridge filter is they don't remove phosphates from the water, but these two have a way to remove phosphates. So if you have a lot of phosphates, you will eventually have algae in your pool. So but if you use sand or AFM, they won't. But the problem with sand is it provides at 20 meters per hour, it provides a filtration quality of at around 20 microns. Okay, and AFM at 20 meter per hour provides a filtration quality of 1 micron. So the water is going to be a lot clearer with AFM. DE filter also provides filtration quality of 3 micron, but the problem is it doesn't remove phosphates. Therefore, you cannot do algae control. Okay. So, with that aside, so now that we have 8 meter per hour and we are choosing a filtration rate, So usually an economical filtration rate for residential pool is at around 30 meters per hour. Okay, and what you can do is you can do 8 meters per hour, which is your hourly filtration rate, divide by 30 meters per hour. Okay, and then the answer you will get is 0.2667 meter square, right? So meter and meter cube gets minus, so meter square. Now you have to find a filter that has an area of 0.2667 meter square. You can just go to any website, Hayward, look for their sand filters, and find a sand filter with 0.2667 meters square. Okay, instead of using sand, just use AFM and you'll be able to get 1 micron filtration quality. Now the next thing you want to have is how to choose the right pump. So there are 2 kinds of pumps. First of all, there's a single speed pump, and there's a variable speed pump. Okay, now if you're using a cartridge filter or a DE filter, it's okay to use a single speed pump. Why? Because when you're cleaning cartridge or DE filter, you have to remove them out of the filter, right? So you have to stop all the operations. You have to remove this DE filter out of the filter, and then you need to pressure wash it, right? With a water hose or something. You just have to use that, and then you can put it back in here and start again. So this is the single speed pump. So what that means is it's just 1 speed throughout the operation of the pump. Now a variable speed pump, you can control the RPM or you can control the frequency. Therefore it's also called the variable frequency pump, right? Usually they have a variable frequency drive installed within the pump. That's why it's called a variable speed pump. So now this pump, you can control its speed, which is very important because you need higher speeds for an event called backwash. Now backwash is how you clean a sand filter. The sand filter is very easy to clean, right? So it has this is, let's say, the filter. This is the filter, and it has a head on top with a say a handle, and all you have to do is just rotate it clockwise and it will change. So you can do vacuuming, or you can do filter, right? Or you can backwash. So it's as simple as that. That's how easy it is to clean a sand filter. Now when you rotate it to backwash, you need a higher flow rate. So in order for you to have a higher flow rate, you need the maximum speed from the pump. But while filtration, you need a slower speed of the pump. You need a slower flow. So same thing again, it's 0.2667 meters square. Okay, this is the filter area that you have. Now all you have to do is, your filter media has a specification for backwashing as well. So sand backwashes at 50 meters square, and AFM actually is 50 to 60. As your sand filter gets older, the backwash rate also goes higher. Okay, so AFM is at around 40 meters cubic. Okay, so let's say if you were using sand, the amount of water you would need for backwashing. So backwashing usually only lasts for 10 minutes. For AFM it's 4 minutes. Okay, so in sand that would be 0.2667 times 50, or let's say times 60, just worst case scenario, right? Times 60, so that would be 16 cubic meter per hour. Now you can divide this all by 60 minutes, and that would be 0.2667 liters per hour. Oh, sorry, per minute. Okay, and since you're going to be backwashing for 10 minutes, you simply times it with 10. So now you'll be using 2.667 times, okay, 1000, which is 2667 liters for 10 minutes. Okay, so this is your sand. Now if you were using AFM, that would be 0.2667 times 40, which would be 10.668 cubic meter, right, per hour. Now you divide it with 60 and your answer would be 0.1778. Now since you only need 4 minutes of backwashing, right, so times it with 4 and you have 0.7112 times 1000, and the answer is 711 liters for every 4 minutes. Okay, now you save money first of all. So every backwash with sand, it consumes around 2667 liters, while with AFM it's only 711 liters per every 4 minutes. So every backwash you save 1955 liters. So over the course of the ownership of the pool, you will have saved a lot of money. So basically that's how you design your sand, that's how you design your filter. This way, if you're using AFM and you're getting 1 micron filtration quality, plus you're using a flocculant, like if you use a flocculant like APF in the pool, then you'll get 0.1 micron filtration quality. And since your water is being filtered so effectively, your chlorine consumption will also go down. Okay, so instead of using 100% chlorine, now you will only use 20%. So there's a reduction of at least 80% of chlorine. So if you use low chlorine, you'll have low chlorine byproducts, and these byproducts are usually toxic, so that will improve. No more chlorine odor, first of all, right? No more itchy skin, no more sore eyes, rashes, nothing. Okay, and that's how you design your filtration system. If you have any questions, just leave a comment below and I'll be happy to answer. See you in the next video.